Assalamu alaikum. This question is on the center of mass and momentum. 3 uniform thin rods, each of length 20 centimeters, form the shape shown. Each of the vertical rods has a 20 grams. This is a vertical rod, this is a vertical rod. While the horizontal rod is 60 grams. What are the x and y coordinates of the center of mass of the system, respectively? So in order to find the center of mass, we can redraw the shape here. This is x, this is y. So we have this massive relative to the other rods, and this one less mass, and this one less mass. This is L equal 20 centimeter. This is L, L, L. And the mass of this is 60 grams, while the mass of this is 20 grams, and the mass of this is 20 grams. So in order to find the center of mass, we find the center of mass for each coordinate. So the x center of mass should equal sigma mi xi divided by summation of all masses involved. So here we have 3 masses, so it's I from 1 to 3, I from 1 to 3. And similarly also for the y center of mass, which is sigma mi yi from I equal 1 to 3 divided by summation of all masses from I equal 1 to 3. So the x center of mass should equal. So we find each mass, the x coordinate. So for this mass, the center of mass for this bar, this vertical bar, will be located here. And the center of mass for this one will be located here. We use another color. This center of mass will be in the middle, here. So now, the x coordinate for this center of mass will be 0. So for the first one, the mass is m1 multiplied by 0 plus, for this one, the x center of mass will be the mass m2, which is 60 grams. So we'll call this m2, this is m1, m3. So it is m2, which is 60 grams, multiplied by the center of mass, which is half this length, 20. So it is basically L over 2, plus the center of mass for this is will be located here, which means on the x-axis, which means m3 multiplied by L. Now this all should be divided by all the masses involved, not even the one that gave a 0 coordinate for the center of mass. So it will be m1 plus m2 plus m3. And this will yield, this term will be 0 plus m2 is 60 grams multiplied by L over 2, which is 10, plus m3, which is 20 grams, multiplied by the center of mass L, which is 20, divided by 20 plus 60 plus 20 grams. And this will give 600 plus 400 divided by 100, which is 10 centimeter plus. So the x center of mass will be located at x 10 centimeter. Now we look for the y center of mass for this system. Similarly, so m1, this is m1, multiplied by its y coordinate. Here it's minus 20 because the length is 20, so it should be located here at minus 10. So it should be minus 10, plus m2, which is the 60 grams. I'll write it later on. But the y coordinate for this one will be 0, because the y coordinate for this point will be at y equals 0, plus m3, which is this one. And the y-coordinate for this one will also be minus 10. The y-coordinate for this point will be minus 10. So m3 by L over 2, or also minus 10. So this is divided by m1 plus m2 plus m3, all the masses. So this term will be 0. And m1 is 20 by minus 10 plus 0 plus 20 by minus 10 divided by 20 plus 60 plus 20, which means this will be minus 200 plus minus 200, so it is minus 400 divided by 100, which equals minus 4 centimeter. So now the center of mass for the system will be located, let me make it here, a simple drawing. This is y, this is x, located at 10 and minus 4, approximately here. So this is basically the R center of mass of this system, which is made of x center of mass I hat plus y center of mass j hat. Thank you. Assalamu alaikum. This question is on center of mass and momentum. A 2,100 truck traveling north at 41 km per hour turns east and accelerates to 51 km per hour. What are the magnitude and direction of the change in its momentum? So we have this truck, and the truck is traveling, so the truck is traveling north at 41 kilometer per hour. So this is the velocity initial, 41 kilometers per hour. And then it turns east and it travels at 51 kilometer per hour. And this is V final. Now we need to find the change in its momentum. So the change in the momentum equal P final minus B initial. So P final is M truck, V final of the truck. Okay. Minus M of the truck, V initial of the truck. So the mass of the truck is 2,100 and V final is 51 I hat, because it's on the this is the V final, it's along the positive x-axis, minus 41 j hat. But remember, this is in kilometer per hour, so we need to convert it to meter per second to make it SI unit. So we need to multiply this. So each 1 kilometer is 10 to the power 3 or 1,000 meters, and each 1 hour is, this is the conversion factor, is 3,600 seconds. So as a result, delta B, change in momentum, will be given as magnitude, will be given as 2,100 multiplied by 10 to the power 3 divided by 3,600, and we take the square root of 51 squared plus 41 squared, and this will yield the magnitude of this change in momentum, 3.8 10 to the power 4 kilograms meter per second. Now we found the magnitude of the change in the momentum. Now we try to find the direction. So delta B, so theta, we have now, in order to find this angle, we have delta B equal to 2,100 by 51 I hat, okay, by 10 to power 3 divided by 3,600 minus 2,100 by 10 to power 3 divided by 3,600 by 41 j hat. So we have these two components. This is the delta B is equivalent to delta Bx I hat plus delta B y j hat. So to find the angle theta is basically tan inverse of delta By over delta Bx. And as a result, it is basically this delta By divided by delta Bx, but we see that all these constants will disappear. Only I have the minus 41 divided by 51, and this will give that theta should equal 39 degrees south of east. Thank you. Assalamu alaikum. This question is on momentum and collision. Two bodies A and B, each of 2 kilogram mass, collide. The velocities before collision is given, VA 15 I hat plus 30 j hat and VB minus 10 I hat plus 5 j hat. If after the collision, VA prime, which means prime means after the collision, is minus 5 I hat plus 20 j hat, find VB prime, or the final velocity of P after collision. So this is basically a classical question on the momentum. So we have two masses, MA equals MB, which is 22 kilogram, and we want to find the final velocity of B after collision, which means according to the conservation of momentum, B before should equal B after. So B before is made of B before of A plus B before of B should equal B after of A plus B after of P, which means this is made of M1 or MA VA plus M2 or MB VB should equal MA VA prime plus MB VB prime. So this is what we want to find. This is the velocity final. This is what we want basically to find. Okay? So we substitute for the values given. First of all the masses can cancel out because it's 2 kilogram. So I can cancel this from all sides. So VA is 15 I hat plus 30 j hat, and VB before is minus 10 I hat plus 5 j hat, and should equal the velocity of A after, which is minus 5 I hat plus 20 j hat plus the unknown, which is VB prime, this vector. So I can just rearrange. So VB prime will be in one side, say like this side, and I can move this here. So it will be first 15 I hat with minus 10 I hat is 5 I hat, and 30 j hat with 5 j hat is 35 j hat. And then I can take this minus 5 to this here, so it will become plus 5 I hat, and this 20 to the other side minus 20 j hat. So this will yield that VB prime, which is the final velocity of B after collision, is 10 I hat, 5 I hat plus 5 I hat, plus 15 j hat, because it's 35 minus 20. And of course, this is in the units of meter per second. Thank you. Assalamu alaikum. This question is on the center of mass and momentum. A particle of mass m moving in the positive x direction with a speed u collides with a particle of mass 2m at rest. After collision, the m particle scatters with a speed u over 4 in the positive y direction, and the 2m particle moves with the speed v, making an angle theta with the positive x direction. Find angle theta. So we can make a simple drawing, which is necessary to solve such a question. So initially we have this particle of mass m moving with a speed u, or velocity u, to the positive x direction as stated in the question. And it will collide with a bigger mass of mass 2m, and it is at rest. So initial equals 0. And after the collision, the smaller mass will be moving in this direction with u over 4 velocity. This is the smaller mass. While if this is the positive x, then the bigger mass will be moving with this velocity, making an angle theta with the positive x coordinate. So this is basically m, this is basically 2m. So in order to distinguish them further, this is big, the big mass, which is this mass. Now, according to the scheme, find this angle theta with all the information given. So basically, this is a two-dimensional elastic collision. So we need to apply the conservation of momentum. So P before should equal P after. And this is a vector quantity, and it's two-dimensional, so we need to write for each coordinate, we need to write this equation. So means P before x equal, not necessary, B after x, and B before y should equal P after y. As a result, the x before, the x momentums, is this momentum, which is m by u for this particle. This one is initially at rest before, so the x momentum will equal 0. And this should equal the, for this particle, the smaller one, there is no x momentum, so it is 0, plus this one will have a x component of the momentum, but we need to, of course, derive it into its, analyze it into its components. So this is basically, this is the x component. So this basically is 2m v cosine theta. And this component is 2mv, 2m because the mass is 2m, 2mv sine theta. Now we can use the x component after the collision for this mass, the 2m. So it is 2mv cosine theta. Notice that according to the sign convention, this points to the right, so it is positive. This points to the right, so it is positive. This is 0, and this has no x component for the momentum after the collision. So now we can leave this as equation 1, and we can write similar equation for y. For y, notice that before the collision, this mass doesn't have a component for the momentum before, so it is 0. And similarly, this one is at rest before, so it is also 0. Should equal, the y component of this is a positive component because it is along the positive y, and it should be m multiplied by the new velocity, m divided by 4. And then the y component of the momentum for this particle, the massive one, is pointing down to the negative y. So I should use negative sign minus 2mv sine theta. Now this is now equation 2. Now clearly we're looking for angle theta, and we have here the masses we don't know, so, and even the u we don't know, even the v we don't know, so we can think about dividing an equation by another equation to get rid of those common parameters. So we can take this, for example, to this side, so mu will equal 2mv cosine theta, and this is mu over 4 will equal 2mv sine theta. So this is 1, this is 2. Now if we divide 2 divided by 1, for example, it means this equation by this equation, we can get rid of all these common factors. So which will yield 1 over 4 should equal 2. Divide this by this will equal 2mv will cancel, and mu will cancel with mu, so it will be tan theta. As a result, theta will equal the tan inverse of this 1/4, which means that theta should be 14 degrees. So this angle will be equal to 14 degrees. Thank you. Assalamu alaikum. This question is on the center of mass and momentum. An object of mass 15 kilograms initially at rest explodes into two pieces of masses 10 kilogram and 5 kilogram. The velocity of 5 kilogram is 4 meters per second along the positive x direction. Find the kinetic energy of the 10 kilogram piece. So this is basically similar to collision, but in reverse, which means explosion. So we can say that P before, according to conservation of momentum, should equal B after. So initially, we have the object, we have one object, so we can make a simple drawing. This object is made of 15 kilograms. When it explodes, there is a fragment of 5 kilogram. So this is before, write it like this, and then after, there is a small fragment of 5 kilogram moving with velocity 4 meters per second in the positive x direction. So this is 5 kilogram. And there should be another mass of 10 kilogram, the rest of the 15. And we don't know where is the direction of its movement. We can find it from the equation. So we need to find V of the 10 kilogram after. Okay? So according to conservation of momentum, before the collision, this particle was at rest. The big particle, the original particle. So this means that it should be before, the only momentum due to this particle is 0. And after the collision, we have two pieces. This one is the 4 mass by the 5 mass multiplied by velocity of 4 in the positive x direction, plus the second mass, the 10 kilogram, multiplied by a velocity we don't know. So this is V of the 10 after. As a result, we can take this to the other side. So minus 20 should equal 10, V 10 after. So V 10 after will equal minus 2 meters per second, which means that logically this particle, because of the negative sign, this piece of the fragment will be moving to the left with 2 meters per second. Okay? So now we need to find the kinetic energy of the 10 kilogram piece, this piece. So the kinetic energy will equal half mv squared, which is half multiplied by 10, its mass, multiplied by v squared, which is minus 2 squared. And this will give 20 joules. So this is the kinetic energy of the big fragment. Thank you. Assalamu alaikum. This question is on center of mass and momentum. Two particles of masses 3 kilogram and 5 kilogram are moving with velocities, initial velocities, the 3 kilogram minus 3 I hat plus 4 j hat meters per second, and the 5 kilogram is moving initially with 2 I hat plus 3 j hat. Then they collide completely inelastically. Find the velocity of the center of mass after collision. So we have two objects, and we can rewrite the velocity of the 3 kilogram here as minus 3 I hat plus 4 j hat meters per second, and the v of the 5 kilogram as 2 I hat plus 3 j hat. Then to find the velocity of the center of mass after collision, so we have two components because it is a two-dimensional problem, and we need to find the x, and we need also to find the v center of mass after collision along the y coordinate. And this one will be due to m1 v1 x plus m2 v2 x divided by all the masses, m1 plus m2. And this one, along the y, will be m1 v1y plus m2 v2y divided by the both masses, total masses. So now we have the first mass is a 3 kilogram multiplied by its x velocity initially, which is minus 3, plus the second mass, which is 5, multiplied by x velocity initially, which is 2, divided by 5 plus 3, or 3 plus 5. And this will give a velocity, the center of mass of the velocity of the combined system will be 0.125 meters per second. Now we can substitute also along the y. So the first mass is a 3, v1y is 4, then the second mass is 5, and v2y is 3, divided by 3 plus 5, m1 plus m2, and this will yield 3.38 meters per second. So this is now we can write a combined vector for the velocity of the center of mass. So v center of mass, the x component will be 0.125 meters per second I hat plus 3.38 meters per second j hat. Thank you very much.